So in this third lesson of Unit 2, we're going to talk about molar mass. So molar mass is going to be really important too as we go through our conversion, so you're going to need to know how to do this. So essentially, the average atomic mass is given on the periodic table, and it can be expressed with units of grams per mole based off of what we were just discussing in our last lesson. So this means that the mass of any one mole of any atom of that element has that many grams for each mole of that element. So for example, carbon has 12 grams for every mole, magnesium has 24 grams for every mole. You can see those numbers underneath the symbol on the periodic table. So when we say the molar mass of carbon is 12 grams per mole, the molar mass of magnesium is 24 grams per mole. This we can use to calculate in conversions. So we can calculate how many grams of the atom we have if we know the moles, and how many moles if we know the grams. So the mass in grams of 1 mole of the substance, so for example, molar mass of nitrogen is 14.1 grams per mole. We need to calculate the molar mass of the following. These two are pretty straightforward since you just get them off the periodic table. So if you looked at the periodic table, you would find that the molar mass for sulfur is 32.01. General rule of thumb over here, as you can see. So I generally keep 2 decimal places when I record for periodic table. So for example, for carbon, I would read 12.01. Chlorine, I would read 35.45. So for sulfur, I would read 32.01. So you can write down if you'd like 32.01. And this would be in grams per mole. Always watch your units here. So you just read that off the periodic table. So for potassium, if you read that off the periodic table, you would get 39.10. And this would be in grams per mole as well. Okay. So at the bottom here, calculate the number of copper atoms in a 63.55 gram sample of copper. The first thing you would need to do is you would kind of set up a conversion using that number first. So 63.55 grams, and this is copper. So the next step you would do is you would use the molar mass you get from the periodic table like we've been practicing. So under copper, it would be 63.55. So you'd write that like this. So you would show that in 1 mole, as you wrote here, there are 63.55 grams of copper. So your next step would be to write out that in 1 mole there are, that number we were talking about yesterday, the 6.02, I would write that all right here, 6.02 times 10 to the 23rd. But if you look, this number is going to cancel with this one. So this problem is pretty easy because you're left with just 1 times 6.02 times 10 to the 23rd. So your answer would be 6.02 times 10 to the 23rd. Okay? All right, so here's just a bunch of practice. So this is how you find the molar mass of compounds. You essentially just add up everything that's involved. So for water here, this is the molar mass right here. For hydrogen that you'd find on the periodic table, this one's for oxygen. You would multiply by 2 right here because there's 2 here. So you need 2 hydrogens. And there's only 1 for oxygen as a subscript, so you would just take 2 times 1 plus 16. Okay, so your answer there would be 18.02 grams per mole. For a molar mass of this compound right here, so barium nitrate, essentially what you would just do is you kind of add up everything involved using the periodic table, and you would get your total molar mass of 261.35 grams per mole. So water, there's another example just for you to try on your own, but that is the one that we did up here. Carbon dioxide, what you would do is you would find the molar mass for carbon, which is 12.01. And as you know, there's no prefix there, so that's just one of them. And then you would add 2 times 16, which is the molar mass of oxygen. And then you can add those up and get your final answer. It's around 44. Okay? So you would do that kind of thing for each of them. So go ahead and give a couple of those a try. Now, when we talk about doing conversions, we're kind of adding another layer onto this. So from this one, we would start with 5.6 grams of carbon dioxide. So you would write out whatever number you're given with is what you're going to start with. Okay, so 5.6 grams of CO2. And then you're going to want to use your molar mass conversion. So like we did on the last slide, carbon dioxide would be 12 plus 2 times 16, which is around 44. And that's in 1 mole. And then we want to know how many moles. So that's actually all we have to do here. We're going to cancel out the grams, make sure this cancels, so we're left with just moles. So you go ahead and calculate that out. So if you take 5.6 divided by 44, you're going to get 0.127. So that's pretty straightforward. You just want to practice using this kind of conversion here. And then we're going to be building on these conversions and actually using another, we might use another step in the future where we add 1 mole here. And then we use that number here, so the 6.02 times 10 to the 23rd. So that's what you would do if you were asked to find out the number of maybe molecules of carbon dioxide. But since we are just looking for moles, we don't need to worry about any of this right now. Our answer would be 0.127. So go ahead and give a couple of these a try as well and see how you do with them. As you can see, there's plenty of examples here, but they're all just going between grams and moles once you use the conversions that you have with the molar mass when you look at the periodic table. Okay? And then the homework that I had assigned is just some more to practice. So in part A here, essentially what you're doing is you were practicing calculating molar mass, and then you were kind of using it here in a couple of conversion problems. That also kind of reviewed some of the conversion problems dealing with moles.